Hi everyone. So I'm very happy to be with you today. Okay, so I'm gonna present Interstellar Lab and what we're doing at Interstellar Lab. So we're working on building bioregenerative worlds. So what it means is that we're using a technology. We're using technology and we're combining it with biology to help designing system that can help human live in a sustainable way on this planet first, on Earth, and in the future. We hope on the Moon and then on Mars. So what the company is doing. So we work on designing and building pods. And this is more specifically the product we've been developing. So we've been looking a lot at how space, what are the systems that are needed to live in space, from water system, air management system, food production system. And we've been designing modules that are completely closed, completely environmentally controlled, where you can grow food and at the same time recycle the air, the water, and the waste. So the way we designed the pods is for them to be working as standalone. So it's composed of different units, the different pods that you can see on the slide, or they can be plugged in together and then form a complete station. And we named the station EBIOS, which stands for Experimental Bioregenerative Station. So that's the experimental bioregenerative station that you can see right now. So how we conceptualize, how we've been designing it, so to be able to support a sustainably life of human on Earth and in space. And here, most specifically, EBIOS is mostly designed for space application. And this is our vision of how we could build a sustainable moon base on the moon through the NASA program Artemis and NASA and ESA program. And so what you see right now is what you find inside one of the 3 domes dedicated to biological production. Here is the aeroponics unit, which is plugging into the greenhouse unit where we grow different trees to fulfill. The greenhouse unit is designed to fulfill the physiological need and also psychological need of humans. And we have the latest unit, which is the treatment unit, where we treat the organic waste that is coming from the greenhouse and the aeroponics units, and we purify the water that is coming from the habitat section. That's the habitat section here. And so you have the circulation units, and everything is connected through the mission control units. So the way we've been designing the module, and really this one is for space application. We also do terrestrial application, and we'll deep dive a little bit more about that. So how we use space back on Earth. And so the different pods can connect to each other through this mission control units. At each door of the mission control unit, you have an airlock, which allows us to have a system that is completely sealed and closed, and you have basically no pathogens going from one dome to another dome. The first unit we've been developing, and this is where I wanted to go about the applying space technology back on Earth. So the first unit we've been focusing on is the biopod. So the previous speakers talk about food production and sustainable food production, and how it has become one of the main challenges for us, for humans on this planet right now, and we need a lot of entrepreneurs and people to focus into this topic. And so one of the units that you've seen on the previous slide is dedicated purely to food production. And what we've been working on at Interstellar is really to take the system and to play that on Earth so we can develop a sustainable food production system. And that's exactly what the system is about. So by taking basically the approach of having something that is very easy to deploy, very modular and very durable, we design, and we're currently building those domes, the biopods, to recreate completely sealed, environmentally controlled environments where you'll be able to recreate any atmospheric and climatic condition, and therefore grow any type of food, but also use it as a shelter to preserve biodiversity. So what you see here coming from the space approach and the design that we did for the sustainable moon base, so it's a deployable system with an airlock door at the entrance, a composite base, and an inflatable membrane. So we took back the idea of having a composite base that you found in pillows, for instance, and the inflation of the membrane that is the most easiest way to deploy actually a system in space, and we took that back, and we took this technology to reshape it and to design it so it could work on Earth. So you have this dome that is a inflatable, so a completely sealed and air supported structure. Inside the dome, we integrated it with very advanced technology to control the atmospherics. So we control the level of oxygen. We suck CO2 out of the environment around the dome to push the level of CO2 inside the dome. We control all the water. So you're filling a tank full, you have a tank full of water that is inside the composite base, and we can spray the water to all the plants, and we catch back the water that is generated and that is inside the dome. All of this is connected to a nutrient dosing system, and we have a very advanced LED system and crop cultivation system. So this dome, this biopod is really designed to grow food. So what we've been working on and focusing on is to develop specific aeroponic system, so we can grow any type of plant. So of course we can do leafy greens and strawberries, but we are going after high value plants and more complicated vegetables, flowers or fruits to grow. And so inside the dome we can recreate a very very specific atmospheric and environmentally environment. And at the same time, we have different support for the crop to grow. So not only aeroponics, but we also do substrate-based greenhouse, where we are able to grow dwarf trees for more specific planting. So all of this is designed so we can achieve a very high diversity of crop cultivation inside the dome. And what is very interesting is really by using CO2 scrubbers that are actually used in the International Space Station, water catchment treatment, water air catchment system that are also used in the International Space Station, and by designing a completely sealed environment, and taking this technology that technology and design approach that traditionally are used in space, we actually came up with a product that is offering a lot of advantages and having a lot of solutions that we can apply here, and more specifically for regarding sustainable farming. And with the system that we developed, the biopod, we basically save a lot of water, which is one of the main issues that we have right now in food production. And it's because we have this sealed membrane that is composed of also material that are used in space like aerogel and ETFE and PTFE. So we have the cell membranes, we can capture completely the water, we can take it back and put that back into the system. And we use also aeroponics. So we're saving a lot of water compared to traditional agriculture. We boost the yield inside. So you can compare the biopod to a container, even though it's much more performing in terms of a growing surface area compared to the ground surface, and also the fact that we can really boost yield because this is again a completely sealed environment that is pathogen free, that is sealed from the outside world, and so here we boost the level of CO2, we play with the light, and we are able to grow food in a more sustainable way, and 365 days a year. So compared to traditional farming, it's a huge boost in yield, and we also reduce energy consumption. So one of the main problem that's a lot of people are actually pointing in indoor farming is the fact that it's consuming a lot of energy to produce leafy greens, and indeed recreating an environmentally controlled system can be very energy like power consumption. The power consumption can be very high, but if you manage to design a system where you have an optimized jet vac, air conditioning, again a system that is completely sealed, very very good insulation, and also a system that is letting the light get in, so you can reduce the consumption of LEDs, and that's what we did with the biopod, and so we reduced drastically the consumption of energy compared to traditional greenhouses. Because again, we've been taking a material that has been used in space, aerogel, for its insulation property. We mixed it with another material system, which is a combination of ETFE and air, and an inflatable structure. And we've been able to design and to build a structure that has very, very good insulation properties, but at the same time that is letting the light in, and so which is allowing us to use less LED than traditional farming. So it's very interesting to, there is a lot of criticism about how are we investing so much money into space and how is it helping us on Earth. Anyone who's still asking this question, I will recommend to read the NASA spin-off and to look at all the technology that we're using right now, and most of it is actually coming from space exploration. But more interestingly, I think there is an opportunity by thinking of how we can live on another planet to design the structure, the habitat, and the food production system, so we can learn how to live more sustainably on Earth. Of course, the goal in the product that we're doing is also for it to be completely autonomous, and so the simulation part, the calculation part, the estimation part before the construction of the biopod is super important. And so, of course, you'll be able to monitor all the biopods by yourself, but what we want is a system to be fully as autonomous as possible. So the way we design it is really, we help you select the plants that you want to grow inside, and then we run a couple of simulations to understand what will be the optimum temperature, what will be the optimum atmospheric and climatic condition inside, and then the software is just taking care of everything. So we really want people just to be able, people, companies, firms, space agency, research institutes, to get their biopods, to tell us what they want to grow, so we can identify the right species and varieties, and come up with a perfect condition to grow those plants. And then we deliver a product where basically they can grow anything, anywhere, by not using too much water, not using too much energy, in a very sustainable way. And we want to do that in an autonomous way. So that's why the software part is super important in the product that we're developing. The first part that we actually released a couple of weeks ago, one of the first algorithms we've been working on is a crop selector. I recommend all of you guys to try it. It's pretty cool. I'm very proud of the team. You enter the number of people you want to feed, and you enter the type of diet you're choosing. So if you want to cover all the nutrition requirements, or there is some part if you're in a vegan diet, not vegan diet, and then our algorithm is basically helping selecting all the crops and organizing everything inside the biopods. So giving you the number of biopods you need to have, and organizing all the schedule of crop growing. We took into consideration something that's very important for us is the diversity of the food, because right now one of the biggest problems also in the food production system is that we are only eating 6% of all the plants that we are able to eat on this planet. So diversity and having diversity in the food that we're growing is very, very important. And also, if you want to be self-sustaining and you don't want to end up eating potatoes all the time. So something that's very important for us. And so select the crops and organize everything and all the schedule, and help you basically monitor the biopod. That's one render of some of the application that we have for the biopod. So here it's on Earth. So as I said at the beginning, we're working on Earth and also in space. But so here it's on Earth, and this is actually a use case that we are currently doing with a company in cosmetics, and we are focusing on the flower cultivation. So the cosmetic industry is facing a big problem, which is around sourcing of raw material, and because of climate change and it's becoming difficult to grow flowers in certain area of the world, and not very sustainable to fly to Madagascar to get your vanilla and to bring it back to make a cream or thing like that. So what we're proposing here to to our customers is to build combination of biopods where we can recreate the exact climatic condition that they need to grow the specific flowers. So that's one of the use case of the usage of our technology here on Earth. Here you can see, and that's a render that you might have already seen online, but it's basically how we turn the biopod into a system that is working on the moon, and so this is a render of obviously a sustainable moon base and through the Artemis program. So we are not there yet. Also, to give a little bit more detail about the stage where we are right now. So the company is 2.5 years old. Right now we're building the first biopod. So in 2 months from now, next to Paris, you'll have a biopods running. It's very, very exciting time for the company. But when it comes to design a product that will work on the moon, we have a three years roadmap. And so we need to do a lot of iteration actually on the system, so we can have something that's working on the moon. We need to change the material, different combination of material, because what we have right now is working on Earth, but it's not solar radiation proof. So we will need to add different layers and another set of probably different layers of aerogel. We exploring what we could do eventually with water in the cushion. But more information to come on this. But also what we need to do inside is to change the heating and ventilating system, and to change the system to grow the plants. So we basically, we're going to be ready when it comes to the software. We can use the same software. We can use the same control, the same simulator, and just by adapting some parameters. But when it comes to the hardware, there are a couple of redesign iteration that we need to do before we be able to go to the moon. The Moon Artemis program is actually starting, so 2023, 2024. It's already started on the construction of the rockets. When it comes to the sustainable moon base, it's going to come a little bit later down the road, because before we build the moon base, we need to bring the human back to the moon, obviously. Last but not least, the system and technology that we are developing are we're really looking forward to be able to make an adaptation also that could go to Mars. And this is how all the adventure Interstellar Lab started, is by looking at what it means to become a multiplanetary species, and what if we were living on Mars, what system will be required to live there. And this is how we came up with solution and technology that we can use on Earth right now. But on the long term, and in what we're doing at Interstellar, we want to participate to this Martian vision, and so this is an image that we've been sharing about how we see the biopod and the EBO station that I presented at the beginning, implemented on the red surface of Mars, and of course it's not going to happen right now. We're still a few, I will say a decade away to send human there. Maybe a little bit more. Really depends on the how fast SpaceX is advancing, but we definitely want to contribute. And same, there's going to be more iteration on the design, and especially on the material that we're using, and because gravity is different, so we need some tweaks on some of the hardware system, But in general, it's really the same concept that we're applying, the same concept of modularity, the same concept of inflatable dome, recreating perfect climatic environmental condition inside so you can grow anything. And I really believe that bringing a little bit of the life that we have right now on Earth and bringing that to another planet, I think it can help a lot, open our consciousness and our mind about what's the role of human, how we can preserve, life on Earth. And for me, space is much more of an inspiration regarding how we can improve life on Earth and how we can use technology to preserve biodiversity and to live in a more sustainable way, because you need sustainable system to live in space. So Thank you. Thank you so much. You can feel free to join, to send an email at join@interstellarlab.earth if you have if you want to reach out and if you think you can contribute to our mission. We're a young startup, so two years and a half, and 15 people, mostly based in Paris. We're growing the team. We're hiring a lot of people from indoor farm startups, from again aerospace and manufacturing, as we're manufacturing right now. So feel free to reach out. And I think I have a little bit of time for question. So yeah.